Our universe is full of mysteries. We explore planets, stars, and galaxies. But one of the most intriguing mysteries lies in the heart of matter itself: antimatter. Imagine a world where everything is reversed. That's the basic idea behind antimatter. Antimatter is like the mirror image of normal matter. Every particle of matter has its antiparticle counterpart in antimatter. For example, an electron, which has a negative charge, has an antimatter counterpart called a positron. A positron has the same properties as an electron but with a positive charge. Think of it like this. If you shake hands with your antimatter twin, the result would be catastrophic. That's because when matter and antimatter meet, they annihilate each other in a burst of pure energy. This annihilation is what makes antimatter so fascinating and dangerous. Antimatter is considered the most expensive substance on Earth. It's not found in any mine or extracted from the ground. We have to create it, and that's a costly endeavor. Scientists estimate that 1 gram of antimatter would cost a staggering $62 trillion to produce. Creating antimatter requires powerful particle accelerators, like the Large Hadron Collider at CERN. These massive machines smash particles together at incredibly high speeds, sometimes approaching the speed of light. These collisions can produce tiny amounts of antimatter, but we're talking about a few atoms at a time, not even close to a gram. The process is not only expensive in terms of energy, but also in terms of time. It takes an immense amount of energy and time to create even the tiniest amount of antimatter. This is why antimatter is so incredibly valuable, and why it's often referred to as the ultimate energy source. The annihilation of matter and antimatter releases an incredible amount of energy. This is what makes antimatter so dangerous. Imagine a single gram of antimatter coming into contact with an equal amount of matter. The resulting explosion would dwarf even the most powerful nuclear weapons. This explosive power makes handling antimatter incredibly difficult. Scientists have to store antimatter in special containers called penning traps. These traps use magnetic fields to suspend antimatter particles in a vacuum, preventing them from coming into contact with matter. Even with these precautions, storing antimatter for extended periods is a challenge. The slightest malfunction could lead to a catastrophic release of energy. This highlights the volatile nature of antimatter and why it's often relegated to the realm of science fiction. Despite the dangers and challenges, antimatter research holds tremendous promise. Scientists believe that antimatter could revolutionize space travel. Imagine a spacecraft powered by antimatter. It could travel vast distances across our solar system and even beyond, reaching speeds that are currently unimaginable with conventional propulsion systems. Antimatter also has potential applications in medicine. Positron emission tomography, or PET scans, already use antimatter in a controlled way to diagnose and monitor various diseases. Researchers are exploring other medical applications, including the possibility of using antimatter beams to treat cancer. The study of antimatter also helps us understand the fundamental laws of the universe. Why is there more matter than antimatter in the cosmos? This is one of the biggest unsolved mysteries in physics, and unraveling it could hold the key to understanding the very fabric of our existence.